Hello class, we're going to be looking at Unit 5, Python modules. Now we've already covered Python modules, but what we're going to do today is we're going to look at two additional modules, the math module and the random module. So recall, what are modules? Modules are libraries of Python code. They contain other functions that we can use. They contain other classes which allow us to make new objects. For example, the turtle module, I can make turtles and I can move them around the screen. Now, in addition to functions and classes, libraries can also include constant definitions, and we're going to see a little of that today. Okay, let's look at the math module first. And math, there are some very important constants, the constant pi, the constant e, square root functions, trig functions, sine, cosine, log functions, all sorts. Now, if I want to access, say, the pi constant, I'm going to say math.pi. And if you remember syntactically, what I do is I start off by declaring the library that I want to access, followed by a dot, followed by, either the constant or the function that I want to access within that library. So math.pi. Notice I do not put parentheses after the pi. I do have parentheses here because of the print statement, but I don't have parentheses directly after the pi itself because pi is a constant. It's not a function. It's really, think of it like a variable. Same with math.e. Now you see the square root function right here. In that case, I do put my parentheses here to indicate that I want to call this function called the square root, and this particular function requires an input, a single number. That's the number I want to take the square root of. Now we have the sine function. The sine function, you have to understand what kind of input it requires. The input to the sine function must be in radians, the unit of radians. So if you take in math, you understand algebra 2, you understand that there are different measures of angles. So just like there's different ways of measuring units of distance, we have feet, but we also have meters. Just in the same way, to describe the measure of an angle, we could have degrees, but we can also have what's called radians. So what if I have 30 degrees and I want to find the sine of 30 degrees? What do? I can call another function within the math library that converts degrees into radians. And once it gives me the radian value, then I could feed that into the sine function. Now this is just a sample of a handful of functions within the math library. Like I said, there's so many more, and you can always look it up in the manual to discover other math functions. A very useful one that I could see us using is the math.abs, and it is our absolute function. We give it an input, it takes the absolute value of that number. Okay, the other library we're going to be looking at is the random library. Before I talk about the random library, though, let's just talk about random numbers in general. Why do we need random numbers? For you gamers out there, you want your games to be randomized, right? You don't want the same game every single time. So random movements, random kind of creatures that are appearing here or there. So games for sure. When we model in computer science, we model things a lot. We model real life situations. We might want to model the weather, and we might want to do some sort of prediction of how some hurricane is going to travel. And to do that, we simulate and we generate random scenarios over and over and over again, and we see which are the most likely scenarios that are going to occur. So simulation is another place where we use random numbers. Another big area is the area of security. Nowadays, security is a big thing. We want to encrypt our messages, and we don't want anybody else to be able to read our messages, and so we need to encrypt them and decrypt them. And in that process, there is part of the algorithm, the idea of generating random numbers so that a third party can't hack into it and discover the kind of encoded message that we're sending. Now, computers are actually not very good at generating true random numbers. It's actually quite hard. And so instead, a lot of computers just generate what we call pseudo-random numbers. Now, pseudo-random numbers, what does that word mean? It actually means fake. It seems real, but it's not really. Now, again, I said computers in general cannot generate true random numbers, but that's not completely true. There are some computers that can, and nowadays, as security becomes more and more important, more and more computers are able to with some special circuitry. But again, kind of historically, because so many computers actually cannot, it's very common for programming languages to have libraries that generate pseudo-random numbers. And so it's just a software program. This software program calculates the next number, and it does it in a way that it looks very, very random, even though it's not. So if you actually knew the actual algorithm, and if you actually knew kind of where we were in that sequence, you would actually be able to predict the next number. Okay, so that's the idea of random numbers. Let's now look at the actual Python library that supports it. What's it called? It is called the random library. So we import the random library, and then we start using the functions inside of it. Now we're going to learn about two specific functions. There are more, but we're going to learn two. The first one is called the random function, which generates a floating point number between 0 and 1. And I'm using math notation here with the bracket and the parentheses, where the bracket means including the 0, but not including the 1. Now, I want to bring our attention back here to the notation here. It's a little funny, random.random. It sounds kind of weird. Why? The reason is the first random references the library name, which happens to be called the exact same thing as the function name that generates this floating point. So it's kind of strange the way the Python library writers wrote it, but they have the random library and also the random function that has the same name. That's why it looks funny, random.random. Okay, that's function number one. Function number two. Function number two, instead of generating a floating point number, generates an integer. So rand_range generates an integer within a certain boundary. So just like the range function generates a number or a sequence of numbers starting from A up to B but not including the B, rand_range generates a single integer that is between the value A and up to but not including the value B. So suppose I wanted to roll a dice and I wanted to kind of get a random number from 1 to 6. What would I do? I would say random dot rand_range starting from 1 up to 7 but not including the 7. So this would be the way I would generate a number, a random integer from 1 to 6. Okay, so that works really nicely for integers, generating a range of numbers. But how about for floating point? Floating point, this random function only generates numbers from 0 to 1. What if I want from, say, 0 to 100? What do I do? What I can do is I can do some arithmetic on it. So this is what I mean. I could do some multiplication upon it. I could do some addition upon it. So let's break this down to see what happens. Now, random.random itself generates a number from 0 to 1. Let's multiply that number by 3. If I multiply it by 3, the minimum value will be 0. The maximum value will be 3. So now, the range of my random number has kind of grown to 3. What happens if I add 2 to it? So in this case, the minimum value that will ever happen will be 2, and the maximum value will be 5. So by doing arithmetic, I could do kind of a similar trick, I can get similar results of getting a random floating point between two different numbers, just like the rand range. The difference is one generates a random floating point, whereas the other generates a random integer. Okay, so that's our lesson for today. I'm going to stop here with this last try problem, and I want you to do each one of these right now, if you can. Pause the video, do this, and at the count of 3, I'm going to show the answers. So 1, 2, 3. First one, generate a random integer, so I'm going to use the rand range, starting from 1 up to but not including 101. Okay, floating point, random.random. Now I want to add 5 to it so that the 0 to 1 moves to 5 to 6. The last one, this is the answer. I take the number that's from 0 to 1, I multiply it by 4, and I add 6 to it. Okay, that's it for the lesson for today. Have a good day, everybody.